My name's Sergey, and I'm a principal solutions architect at Amazon Web Services. Yeah, I constantly forget about it. We mentioned logs, tracing, some metrics, whatever, some complicated things, how those are instrumented, how processes are set up, and all this kind of stuff. So how do we actually approach the observability at Amazon Web Services? And how do we actually see that at our clients? So I'm telling you, there's lots of approaches, like a lot. But let's tailor it to something that we do, and I will try to map it to what I see in the field, basically from some of you guys probably, I don't know, and from other clients as well. So first of all, observability. Let's forget about some like terms, definitions, whatever. The thing is, it's a process basically. So you will never get the perfect observability like ever. It's just get on with it. It's fact. But it's a constantly changing and evolving process. So how does it work for us, for example? I don't have much time, so I will try to make it snappy. So basically, yeah, basic things. We have alarms. We have systems that are going like constantly break, and something goes off. And we have alarms which are actually actionable. That we can do something about it, and there is not too much noise about these alarms. Okay, fine, there's alarm, something went off. We dive deeper into the process. We go into the logs, traces, whatever. We find the reason. Fine, okay. But all these mechanical things are just a part of the whole thing. So basically, what we do afterwards is no less important at what we actually do is the operational reviews, or how we actually call them. There is a nice name to it. I constantly forget it. COE, yeah, correction of errors. So that's actually a process where the team just sits together, looks at what happened during the operational event. They look at the dashboards and they're trying to understand what the hell went wrong and why didn't we get enough information. So just a simple, super simple case. We just recently had a customer who had a huge spike in the load, and I've been in the debug session with this customer directly. And we open up the dashboard and we have no idea what to look at. It's like, okay, some CPU, some memory, so what? It's like nobody knows what's happening. And that's like really, really common. And because the customer doesn't have this process of actually understanding what are they looking at and why are they looking at, and they don't have a process to enhance it. And for us, basically, okay, teams, like 2 pizza teams, yeah, everybody knows that. So those 2 pizza teams, they have this COE process, fine. But it all goes up, and it adds up at every week meeting. It's like a large operational meeting where lots of our teams are coming together, and there's thousands of engineers, and there's lots of our management sitting there, and everybody's looking at what's happened at major hookup, so issues and wins. Yeah, it's fine. And everybody's engaged in the whole thing, and we make these changes to all together. So we review the most important dashboards, and we review the processes, and everybody's engaged, and things are happening. So that's in a nutshell what's happening. But let's talk about how do we actually find the problem. The analogy I will be using is the needle in a haystack analogy. So we need to find that needle. So something went off. Okay, fine. You have a whole hay of microservices, something like this. So it's good luck. Okay, fine, find it. If you're lucky, it might be, I don't know, here. No, maybe here. I don't know. So what happens next? So yeah, which haystack are we looking at? No idea. So yeah, so dashboarding. Obviously, yes, everybody loves dashboards, and they build dashboards, graphs, and whatever. We also love dashboards, and there will be actually a whole section on it. How do we build them? But okay, yeah, we find the dashboard, something's off, but the haystack is still wrong. Okay, so back to the question that was asked before. So it's how do we actually identify this microservice where the problem is? And the answer is yes, it is traces. So we actually create this mechanism that shows all our microservices on a map, and it tells us where exactly the issue is. So we identify the microservice, We go to the dashboard of this exact microservice. Okay, we look at this dashboard, fine, there's some issue, and I don't know, memory is off, CPU is off, whatever. And then we dive deeper into logs, we correlate them with these traces, as it was set already, and yay, we finally find the issue. So yeah, how it looks like in the practice, let me actually quickly show you. I won't spend much time on it, but so back to our puppies website. So that's our website. There's a plenty of small microservices which are interconnected with each other, and we can see, for example, this service. I will try to zoom it in. Nope, wrong button. This button. Yay! So you can see this service signals about some errors. Okay, fine. So we click on the service. We go to the service dashboard. We can see things like, okay, some metrics which are related to the service, and we can actually see things like more high level, like response time distribution. Okay, you can see something is wrong here. So we go here, we filter the data based on this latency tail, and we see the traces which are related to this issue. Okay, we can basically filter them out, pick the trace itself, go to the trace, we can see which services are there, what are the issues, and we finally find our issue here. So the S3, some access, the logs, whatever, like lots of information. So, but you get the idea. And yeah, just a small disclaimer. I'm talking about the AWS services here because, well, I'm from AWS. Hey, but thing is, it's not, all these tools are not exclusive to AWS. So you can use Grafana, you can use OpenSearch. It doesn't matter. Basically, all of these services, they have similar mechanisms. The thing is, the idea is there. So that's how you actually approach the situation. So let's talk about the practices of how do we build the whole thing. Yeah, plenty of whatever. So yeah, starting with the traces. So again, what the hell is tracing? Tracing is basically the way to attach small piece of information to the request which passes through your system. So once it hits your load balancer, service, whatever, we attach this small thing. It's called trace ID. It's auto-generated, and we propagate this trace ID through the whole system, through all the related microservices, and at each part of this path, we record logs, metrics, etc., and they are correlated with this trace ID. Yay, we have the whole chain. One small thing to mention: there might be like a small website here, hiding hiding here, but it might be like a huge application with millions of requests. Just as it was said, yes, you might spend a lot of money on it because the traces are, you have to record each trace. So there is so-called mechanism. The mechanism is so-called sampling. Basically, when you sample the small amount of requests out of the whole amount, and that actually helps you to save the money on this whole chain. That's how we actually do it. But it depends. If you have some very important operational thing and you need to see all the traces, you just reduce the sampling. You just remove the sampling and you trace all the requests. There will be a shit ton of information, but yeah, you have all you need. Next, dashboards. Yay, we love dashboards. Everybody loves dashboards. No, they don't. Okay, fine. But we do at Amazon, and we actually do a lots of work with dashboards. As I said, there is a COE, there is a processes to review the dashboards. Our leadership team knows about our dashboards and what's happening on them, and we actually focus on the audience that looks at the dashboards because there are different kinds of those. It's not like it's all about some metrics, It's like, okay, there is an event happening and our leadership team wants to see the impact on the customers, and they look at what? CPU metrics. They look at, some timed, memory metrics, whatever. So we focus on the audience. We work backwards from the customer. That's why there are lots of different dashboards here. So for example, customer experience dashboards, that's the top one. So this one is actually focusing on the business metrics mostly. So the data here comes from canaries. The data here comes from the real user monitoring. So things like JavaScript errors, CSS errors, latencies, whatever. So you get the point. So, and these dashboards, they are used primarily by the business and for the top level operators to actually see the impact of any change on our system, which actually is made on the customer. Next, there are system level dashboards. Those actually work, well, they basically look at the API. So everything in AWS is API based, and your systems might not be an exception here. So yeah, these system level dashboards, they are basically defined per API, and they show you the API way. So many API words. So yeah, microservice dashboard, those are defined based already on a specific microservice, or how we also call them cells. These are defined for the teams basically. And another one is the capacity dashboard. That's a pretty cool one because it actually looks at how many resources are used by our teams during the operational event, during the lifetime or whatever. So these are used to plan the capacity and the forecast the capacity. For example, we had a World Cup last year, okay? So based on our estimations and based on these dashboards, we can say that next World Cup, we might need X plus amount of resources. So that's basically what capacity dashboards are for. There is additional one, which is not mentioned here. It's usually like CI/CD monitoring dashboards, which are looking at the process of your deployments, etc. But the main thing here is that, well, define the audience first of all, which looks at your dashboard, and what kind of metrics are you planning to show there, and yeah, break them down to your teams if you have any teams. So yeah, so let's talk about how the dashboard looks like. There are plenty of best practices here. So first of all, time series. Business dashboards, the one I mentioned before, they can show you anything like pie charts, like bar charts, something funny and colored and whatever. But for the technical guys like me, for example, we prefer time series. It's the most convenient and simple way to represent the information, and it just works. Additional thing, put the key metrics at the top and make the window for the metric, for the most important metrics, large. People well, we're kind of lazy because we don't want to like look for the important information somewhere down the line. We want to look at the dashboard. It's like, oh, something big, this thing is important. So that's how it works. And from the top, read from the top. So just remember this thing. It's super basic, but it's there. Additionally, not too wide. It's 3 a.m. I don't want to scroll anywhere. I just want to open my dashboard and look at it, and it's like, okay, this thing is here, and if something is off my screen, it will be lost. Like, believe me. Annotations and the time zone. Oh my God. I've seen so many times like people having 2 different dashboards for 2 different systems, and they do not match. It's like there is a spike here, and we're looking at the spike on another dashboard. It should be there, but it's not there. Because why? Because UTC is not GMT. Okay. And that's it. So keep your time zone consistent, please. And even if you don't, just add some annotation that says that, okay, this time zone is X plus whatever. In descriptions, okay, you built your dashboard. Yeah, you're a cool guy and or girl. I don't know, not to offend anybody. So yeah, but you leave the company or you leave for the vacation or whatever, and somebody else just looks at your dashboard and says, okay, what's written here? What's the metrics? And has no idea. So include descriptions. They should include some basic information. You don't need to write a poem here, but just for the sake of those people who actually look at the dashboard afterwards, or for your own sake, because you look at the dashboard half a year later and you have no idea what's happening. Just write annotations. It's a very important thing. Again, yeah, I actually missed that one. So, or have I not? Yeah. So basically, include SLAs or important metrics on your dashboards. So it's like you might not know what's good or what's not for your system. You just might forget it or do not know, whatever. So yeah, range, again, do not put metrics which have like too wide ranges, because there might be some metrics which are somewhere in the millions, and there are like 10 metrics which are in the lower numbers, and they push each other, and you have no idea what's happening. So just include them like properly. Again, avoid clutter. Nothing special here, nothing additional, but yeah, just don't overload your dashboards. Yeah, let me actually do this thing. Yeah, and yeah, just review your dashboards regularly with the teams and etc. It's very important. But that's additional thing. Dashboards, we do not just drag and drop them. It's very convenient, it's very nice, but don't do this. Use code to actually create your dashboard. So this is an example of CDK, for example. You can use whatever you want, but CDK is just something that I like personally. So you can attribute your resource. In our case, it's like API gateway with some additional metrics, and later on you just, with a one-liner, you put them on the graph. Why is it important? Because this way you can actually commit the code that describes your dashboard somewhere. You can version it, you can pass it to somewhere, you can make a module out of it and pass it through the NuGet somewhere to your colleagues. That just works, and that's much more repeatable, and it's a good practice here. CDK ADS, it's back to the conversation that we had before. CDK is pretty nice. Kubernetes is pretty nice. So let's combine two things together, and you can see that you can actually define the resources in Grafana, like dashboards, etc. Same basically. And you can use like a proper language here, not this million-liner YAMLs there. Everybody loves them, huh? Nope. So yeah, dimensional thing. So metrics are a good thing, but we have a lot of metrics. A lot. So, for example, one of the services, let's imagine like IoT devices, which are sending a lot of metrics, or like that whatever system there is that generates a lot of metrics. So if you put every metrics, every second, every metric units in every second to the system, it will incur API requests, it will incur CPU memory resources, it will put your system down the more metrics you have, and you will pay more. Yay. So how to avoid it, and how do we actually avoid it? So basically what we do, it's called EMF, embedded metric format. So what do we do here? So we basically say the values and the configuration of the metrics, they all are put in a single log file. So we just dump these metrics every once in a while in a one single large file, which contains configuration for the metrics and the values for this metric itself. And then we just dump the whole file to the CloudWatch. And that's very nice, because CloudWatch is smart enough to understand what's happening here and actually create metrics out of it. Sorry, next slide. So yeah, this way you don't send like 1 million requests, you don't overload your metric system. And the system, again, it's not exclusive to CloudWatch, because we do use CloudWatch, you might not, it's fine. So there are plenty of systems like this in third-party products. Just look at the mechanism like this, and that will save your life, money, and wallet, whatever. So how do we actually instrument our code? It's pretty straightforward. So basically in Amazon, we have a metrics library, like a common metrics library. It's used for all our products. It's embedded in our libraries. We might pass it explicitly, we might pass it implicitly, it doesn't matter. It depends on the code and its possibilities. We can add additional metadata, and basically that's basically it. You just pass the library that just adds the additional data and it dumps in a single file. It's super convenient. So how does it look like in the real life? So in our case, product info service. So we have the namespace, which maps to the namespace of the metric. Dimensions, not here, but we'll talk about that later. The units, basically, what kind of units are we looking at? And the value itself. Super easy. You might put a lot of data here. It will be just one single file, but it's much easier this way. But let's say we have a spike of something. We have no idea what. So we have number of operations in our product, like get products, which is just a simple key value operation. search products, which is a scan operation, and we have an update product, which is I don't know, just putting the unit in the queue. So we need to define additional thing, which is called dimension here. So the operation, well, in our case, it's an operation. So we identify additional piece of information which says this exact operation did something wrong. And this way we attribute our metrics, and this way we can identify finally that something goes off. So yeah, view dimensions. So yeah, but that's not all. We have very nice concept. It's called high cardinality. So let's talk about dimensionality. So for example, we're talking about latencies for APIs. Oh, I don't know, errors per EC2 instance. Okay, fine. Well, the combination of these two factors basically it's called cardinality. It's the whole spectrum of values that you can get. But okay, there might be just like 3 availability zones. Totally fine. We can get a metrics out of it and look at it. It's fine. But we can have millions of customers' IDs. I hope you have. If not, you have a bad business. So yeah, there is a plenty of customer IDs, and we can tackle this issue in 2 different ways. So first of all, it was actually demonstrated during the previous demo. You can use the Grafana and language, which specifically runs through your metrics and shows you some specific metrics based on some I don't know, query, name, data, dimensionality, whatever. But that's usually is not enough if we have like lots of numbers. So if we're talking about the product ID, for example, yeah, like a lots of product IDs. So we might use things like contributor insights. It's called, in our case, in CloudWatch, contributor insights. In Grafana, it's called outlier detection. But the thing is that this mechanism, it looks at all of your metrics and it finds the top contributors, like top 100 contributors. So it looks at 1 million customers and says, these 100 customers, they are actually bad, or they produce the most latency, they produce the most something because X, because something. So how actually does it look like? Again, puppies, yay. No, there won't be any puppies. There will be a boring thing, contributor. So in our case, it's very simple. So it's a DynamoDB something which is very simple to set up, and the contributor basically tells us, yeah, come on here. Yes, so we have puppies, kittens, and the bunnies, and the puppies actually contribute the most data points because, well, those are predominant on our website, and we have the most clicks for those. It's a very simple example, but you can see the thing. So it's like if some entity within your products produces a lots of metrics, whatever metrics you define, I don't know what your metrics are. The contributor insights mechanisms, they can help you actually tackle this problem and identify the outliers. Again, it's not all. It might be even more complicated than that. So, for example, okay, we have lots of customers. Let's imagine 1 million of customers. Okay, 5 customers are, well, we just roll out the update to the front end, and the customers start to send wrong URLs based on some form, for example, like book something and there's an error. So 5 customers, 1 to 5 customers sending out of 1 million, it's nothing. We might not even notice, we might not even care. But let's imagine it's 10,000 customers. It's 1% already. So we need to do something about it. And that's where we actually need to do something more complex. So we actually need to include the combination of mechanisms. First of all, it's a metric math. So again, Grafana has it, CloudWatch has it, but the idea is metric math, which allows you to calculate the amount of units that you're looking at. And using this contributor insights or whatever mechanism there is, You look through all the metrics and you look on the contributors, you calculate them, you calculate the top contributors, and you see if the percentage of customers out of the whole number is high enough, then you run the alarm. It's a very nice business metric. It's a very nice technical metric. It's just a great approach. Thing is, if you see that there is like 1, 2, 3, 4 elements on dashboard, which you need to look at to identify what's happening, and takes you 1 hour, 2 hours a day, use additional mechanisms like metric maths, use contributor insights, etc., just to make one single dashboard and one single metric. It will save your life. Like, honestly. Log analysis. It's a very nice little tool. Basically, again, it's called Log Insights, I believe, in CloudWatch. Yeah. Thing is that there are lots of logs. How those are getting into your system, it's an additional thing. I will show it. The thing is, there are mechanisms like OpenSearch, aka Elasticsearch. There is a CloudWatch Insights, etc. So the mechanisms that help you to actually write the query to identify the elements in your logs. So again, in the puppies, so you can see I'm looking at the log group for my pay for adoption thing. So there's some complicated query here. So I'm filtering out some puppies and bunnies and whatever. And thing is, I can see how many of those have been requested during some specific time periods, what kind of type was requested. And for example, I can, if the log information contains IPs, I can say from which IPs the bunnies were ordered most. That's the idea. Okay, moving on. There won't be any more complicated things, finally. Except for this one. Love it. Yeah, this is called profiling. And this is the lowest level of debugging that we have to do sometimes. Frankly, there is not much to do to talk about this one, because if you know what profiler is, fine. If you don't, well, go Google it. So the thing is that we, during the operational event, or before operational event, like during the load test or whatever, we do the profiling. Basically, it's a snapshot of the memory and some other resources of the application which does something. So this is the whole timeline at the bottom. These are operations that take the part of this time. So if the operation takes too much time, if it's an outlier and whatever, we look at this operation exactly and we understand that something is wrong and we start digging. But that's basically what profiling is. There might be a remote profiling, like profiling on your desktop, it doesn't matter. So yeah, 3 additional things. Be your own customer. What does it mean? So browser testing. Before I joined AWS, I actually worked as a developer, aka DevOps, aka CTO, aka that guy who knows everything in a small company because nobody. And we very often had issues with the regressions. So what does it mean? It's just you have a web interface and you roll out, you fix some bugs on the web interface, you change the wording, you change the coloring, and you make an update to the system, and these bugs are back. It's like the color is back, the texting is back, and it's called regression. So you might know what it is. And how I tackled it, I actually did a combination of 2 things. I used Selenium. Who knows Selenium? Raise your hands. Yeah, bros. So yeah, it's a pain nobody forget. And an additional thing I used was snapshotting. Basically, I made a photo of the page, and I compared the photo of the page with the next version, like literally. So yeah, if 2 pixels are different, well, there is a problem. So yeah, guys at Amazon were doing the same thing in a much more professional way, I believe. And what they came up with is synthetic things. It's called canaries, basically. So it's again, it's a headless browser testing. What it means is just scripts based on Selenium or Puppeteer, which run against your website, click some buttons, wait for something, look at something, and record what's happening with the page basically, and if the behavior is as expected, as you expect it to be. So basically, that's very simple concept, and you write the scripts, or you can auto-generate the script. With the whole thing is the customer, how to test the behavior of the web page. Well, you just use the scripts like this, which go through elements and basically test the whole thing. That's what our guys are doing right now, and there is a synthetics service which does that, and there's a plenty of other services which do the same thing. But that's not enough. So there is also, well, okay, we click through our interface by some synthetic canary. Okay, fine. But we don't test the device itself. It's like my mobile phone. So how do I test this thing? What's the latency from my mobile phone? What's the HTML, CSS errors? What are the other issues? I don't remember any others. Sorry. So yeah, so that's where the real user monitoring is coming in, and that's again the service which has been built within the deepest cellars of AWS, and it made its way all the way up to the screen. So basically what it is, it's a script which is embedded into every web application or client application. It is literally running on the client's device. It records the console output, it records the errors, etc., etc. In that sense, it's all back to the CloudWatch as some metric. So it can help you to identify how the user actually navigated your app. It can help you to identify lots of things like geos. There are 2 countries in my demo, but I just don't want to switch anymore. The thing is, yeah, just instrument closer to your customers, not only by testing your application, but testing the device itself, because it's super important. Because you might not know that, I know, somewhere in Jakarta, the provider has cut off the line, and the clients from this exact region have problems with latency now. How would you know that? You won't, but they will call you and tell you your application is shit. So, again, alarm fatigue. There's a term to it. So you have a large complex system, you have lots of alarms, and the operator somewhere 3 in the night, because everything happens at 3 a.m. in the morning, they just look at the whole thing and it's like, oh my god, skip, and no issues come over, and lots of information lost, etc., etc., etc. So that's additional thing that we encountered, because we have a little bit of resources to track, and way to tackle it basically is to use the aggregated alarms. Actually, this slide is better, because that's one of the use cases that our customer BT done. Basically what they do, they aggregate alarms on the regional levels. It's like, okay, there is something huge happening in UK. Okay, fine. Then we go down to the London, and then we go to the Sanford, whatever. And the thing is that you aggregate alarms on some specific levels to see to not to overload your operators. You can actually read this article. I will share the deck, because nowhere in the world you will remember the URL. But the thing is, just read this thing, and it's pretty much self-explanatory. And I think I explained it in good details. But how the instrumentation looks like. Time for complex slides. Hey, love it. Because you look on the screen, not on me. So there are 2 ways actually to approach it. So AWS native way and the do-it-yourself way. So basically, there are a number of layers to the whole thing, and how the code is instrumented and how the application is instrumented. So obviously, we need something that collects the logs, metrics, and traces, so-called agents. So in our case, in AWS way, it's a CloudWatch agent, X-ray agent. Pretty logical, which feed the data all the way up to the specific mechanisms like CloudWatch, Synthetics, X-ray. They go all the way up to the higher level services like real user monitoring events, etc. Then we have like additional service lands and AWS native like dashboards, whatever. But the chain looks basically like this. In your case, mostly when you're using the open source solutions. So there are multiple ways to instrument it again. So most most known, I would say, would be hotel, OpenTelemetry. It was mentioned already. There are plenty of others, like Datadog had their own agent, Dynatrace has their own agents, and so basically they all work with the agents. So there is some agent which runs as a sidecar in EKS, in Kubernetes, whatever, which runs as a sub-process on a EC2 machine, whatever. There is some agent which actually looks at your application, receives the trace, metrics, etc. information from this application, which is instrumented before that, and sends the data further on. It feeds the data to OpenSearch, it feeds the data to Prometheus, Jaeger, Zipkin, whatever, and to actually render the whole thing, up to you guys. Now it's your problem, not mine. So yeah, how to basically store the whole thing again. So if you have Prometheus and you run it in the Kubernetes, you need to think how it scales across multiple availability zones, for example, because storage does not travel between availability zones, etc., etc., etc. So you have to think about things which might not be there because this service is not managed. Dashboarding, totally fine. Grafana, it's a great instrument. You can use it actually with our instruments as well. There's a lot of integrations right now, and that's how the chain looks like generally in the fields and what I see as well. There are additional things like Victoria metrics. There are additional things like I don't remember all of them. So yeah, that's a very nice example of a complex system, how it was built by one of the clients, like a large clients. I think it's I actually forgot the name of it. It's terrible. Yeah, I should have not. But the thing is that for your observability mechanism, you have to define the pipeline which can actually be applied to multiple systems in a straightforward and unified way. So you don't want to have 10 different projects, 10 different pipelines, 10 different vocabularies for your observation terms. So it's like these guys calls metrics, and these guys calls metrics, I don't know, numbers, whatever. So you don't want that, and you don't want your services to be named differently. So these guys name service like ABC, these guys called service 1, 2, 3. No consistency, no control, no nothing. So singular vocabulary for your observability, a singular pipeline for all your systems which are easy to integrate, and that's basically how it works within a large and mature applications. Yep. Okay, the photo was done. I can switch. Again, for metrics, yeah, this one was actually for logging, yes. And for the metrics, there is additional system you can actually, I don't know, make another photo, whatever. I'll share it. But the principle is the same. Just one single system which you can first code using CDK, CloudFormation, Terraform, whatever, which you can scale and which you can apply to different systems and have some centralized piece to it, like a logging, like OpenSearch. It's a bit complicated topic because you shouldn't use one single OpenSearch cluster for everything because you will overload it and it will fail and all kinds of problems. But the thing is, there should be some single source of truth of information for metrics, logs, etc. So yeah, that's basically it. There's not much here to tell. It's still a process. There are lots of layers to it. Go through the operational reviews. That's the most important thing, because if you don't know what's happening, if joint teams don't know what's happening, if your management don't know what's happening, you won't have a system. Like, frankly, it will not work. You have to reiterate your dashboards. You have to reiterate your observability, and not just having metrics, which is just random metrics, CPU memory, like tie them to the use case, to the audience that is looking at that metrics, and try to understand what you actually are looking for and how fast do you get the information. So yeah, that would be it. All right.